Hello everyone, a very good evening to all of us. This is my project for skill development lab which is offered in third year of 5th semester computer engineering department SJSITS Indore. So the project attendance adder focuses on adding and processing the average attendance of a month wise or a semester wise attendance input based on the input that the user have provided and convert it into .csv format of Excel spreadsheet. So the technologies for its implementation are React and at the front end and Python framework Flask at the back end. So the process flow of the project include that when the user uploads a particular .jpg or a .png format file at the front end, it gets processed at the back end and it gets added month-wise, and finally after the processing has been done, the output is outputted to the .csv spreadsheet format in the Excel form. So once the user uploads a PNG or a JPG file, it gets converted while processing into a .csv format. So the implementation works like this. We have a front end, we have a back end, and the back end calls for a sub process as the core component of the particular implementation of the code. The front end is built on React as I've already mentioned, and it communicates with the backend with API calls and particularly, and the backend calls the core component which have been written in Python by making it as its sub process, and the main core processing is basically done in this core component. So before talking about implementation of this particular project, we will be talking about the use case analysis of this project. So traditionally and today also many of the systems and libraries use traditional attendance systems which are basically done on paper. Now on paper the storage of the attendance is inefficient and it is mostly error based. So relying on manual calculation can be not reliable, especially if we are working for a large amount of data set. So rather, so if we were to do calculations by Python scripts, it will not only provide a reliable medium for the physical attendance that have been uploaded, but also will be efficient and time saving, and also will be accurate for that sense. So before talking about the core component, we will be talking about the front end and back end API call and communications. So as I've already mentioned, the front end is built using React. So we have a file called upload.js at the front end, which is making an upload API call to the app.py file which is present as a backend. So this API call is responsible for sharing of process information to this backend, and this final backend finally creates a sub process which is known as core.py, which is I have finally include as a core component in my file, which is doing the actual processing that we needed to convert that file into .csv format and for other OCR handling techniques. So talking about the core component, we have 6 set of steps which ensures that the given image is converted into the desired format accurately and reliably. The first step includes initializing the model of paddle OCR. So the OCR or the optical recognition technique is used to extract text from an image which may be in the form of a particular shape, a particular font, or in form of a tables. So in this model, paddle OCR is widely used model which is used for detecting tables in a particular image file. So for example, in this image file, we have some type of English content which has been written, and on the right hand side we have the text which the OCR model has detected. So as we can see, the model is quite accurate in detecting tests which are written explicitly. The second steps involve detecting the table. So as as many of the tables which we are taking picture of contains redundant information in that picture apart from the table which we want to work on. So removing all those redundant information is necessary before OCR production, otherwise it may provide unwanted results. So for example, in this image we have a good quality image of a particular PDF taken, and for that image we have detected this table which needs to be first of all extracted and cropped out, and then it should be sent for further processing into that OCR model, which will all reduce the computation and increase the efficiency of the model. So the second step involves detecting the table which crops out the redundant information into from that image to convert it into the CSV format. The third step is the main step of OCR processing. The image or the table that we have provided, or the cropped image or the cropped table which we have provided, is sent for OCR processing via the model which we have discussed earlier of Paddle OCR, and the model detects and recognizes text based on its deep learning models and returns us the output in three forms: boxes, texts, and probabilities of those texts. The boxes indicate each of the particular boxes that have been detected, and the text inside it detects the text which are present in that boxes. The probabilities indicates that with what probability out of 1.0 the boxes has been detected, because the image may contain redundant information and hence each box is assigned a particular probability which would indicate the accuracy of that particular box detected. So for example, here is the detections that I have taken from a particular input file. We have some of the boxes that have been showed in red color, and this was the image for a particular attendance sample that we have given on group. So for example, the name is detected as name, and this output which has been detected is written on top of it, and as we can see it is quite accurate model which is detecting even the text which are inclined at a particular angle. It is detecting all the printed text which have been shown here, and I have tested it with handwritten text as well, and it is detecting it with quite accuracy. The fourth step which is involved in further OCR production is normalization. Normalization refers to the concepts that when once we have detected the text boxes for a particular image in a particular row or a particular column, then we have to specify that which row and which column this box belongs to. Otherwise this may be manipulative, and this box will not correspond to this particular box in that Excel sheet. For example, the serial number 5 has the name Vinay Patidar, and it has total attendance of 5, out of which he has received 4 attendance. So to accurately map it into the Excel file into the corresponding row with serial number 5, we need to have its corresponding row and corresponding column to detect. So what we will do is, in the concept of normalization, is we'll try to extend the box of each row and each column particularly, and we'll try to overlap all these boxes into that particular row. So for example, we'll take any row, we'll take all the rows, and we'll try to expand these boxes horizontally as well as vertically for that particular row. So once we are done with expanding all of these boxes into that particular row, then our output looks something like this. So after normalization, our output is something like this, where the blue lines indicate the particular row which has been normalized, and a green lines indicates a particular column which has been normalized. Now this contains all of the particular row boxes which have been extended, and for OCR detection it will be highly inaccurate if we were to produce this output. So we need to have one particular box for a particular row and one particular box for a particular column in place. So to remove all other boxes, we have to choose one particular box for each row and each column, and for it we will be basically following the box with highest probability. So the selection of boxes is done on the basis of highest probabilities of all the boxes which are present there per row or per column. So per row and per column, we will try to select only those boxes which had higher probabilities of detection in from that OCR model that which we have initially run. So after normalizing it with highest probabilities, output may look something like this, where the red lines indicate the particular highest probability box which has been chosen per row, and the blue lines indicate the highest probability boxes which is chosen per column. The next step involves intersection. Once we have decided all of the rows and the columns of a particular Excel sheet image that we have been given, we will try to map a particular box which is basically decided upon the intersection of the vertical and the horizontal lines. So how the intersection method works is, the intersection methods calculate that at which point the vertical as well as the horizontal lines intersect, and tries to get the coordinate of the x and y for which the intersection takes place. So for taking the first point out of here, the first point of the box, we are taking the x coordinate of the vertical line. Why? Because the x coordinate of vertical line remains fixed for this particular point. So this is our vertical line, and the x coordinate of vertical line is fixed for this point. That's why we are selecting this point as the first point of our box. The second point is chosen by the y coordinate of the horizontal line that we are taking. Why we are taking y coordinate? Because the y coordinate of a horizontal line is fixed. So that's why we are taking the y coordinate of the horizontal line as the second point of our box. The third point of our box includes the x coordinate of the vertical line that we have taken, and similarly the fourth point of the box includes the y coordinate of the horizontal line that we have taken, which remains fixed. So in this way we are trying to navigate through all the coordinates of detecting a particular box, and will try to see what is the text which have been detected in that box, and try to manipulate with the box which we have already taken, and after applying all the after converting all the unordered boxes into the ordered boxes, will comply with the concept of IOU. So concept of IOU includes that IOU stands for intersection over union. So IOU concept indicates that we are not taking that redundant boxes, and we are trying to take the boxes which we actually need and which actually contains the data. Otherwise we have many redundant information into our Excel sheet. So an efficient OCR detection and OCR to Excel conversion, we are applying a concept of IOU, which basically divides the intersection of the two boxes over the union of the two boxes to calculate the efficient result, and we'll try to see the result for only those boxes which has the maximum IOU. So we'll try, if the two boxes are intersecting, then we'll try to calculate the IOU of those boxes, and the box with the highest IOU will be taken into the consideration. So how the IOU is calculated is that for the intersection, we will be taking the areas, common areas of the two boxes that we have used, and for the union we'll using the formula area 1 plus area 2 minus the intersection part. How this formula comes is, for example, we have two boxes which is intersected something like this. So we have a common part of intersection here, and the union of the two indicates the bigger rectangular box that is shown in the red. So the union turns out to be the area 1 of the particular box which we have chosen, the area 2 of the particular box which we have chosen, minus the intersection part of it. Why we are subtracting the intersection part of it is because the area 1 and area 2 gets adds the intersection part 2 times. So for calculating it one time, we need to subtract it for a time, and hence it will calculate the union part of it which we require. Now for calculating the IOU value, we know that the IOU value is the intersection over the union. So the IOU value turns out to be intersection over area 1 plus area 2 minus intersection. In this way, we'll detect that which boxes are actually redundant and which boxes are actually useful, and will try to derive the information which is basically shown in this text area that we have discussed earlier. So we have identified the boxes based on the probabilities. Now we will be identifying the text which is basically based on those boxes which we have selected. So on when we have this text which is basically based on the boxes, we'll try to store in that array which we have declared it in Python. So the sixth step arrives as when we export the given image into the Excel file which we require. So we have the data array. Now we'll use the pandas data frame and we'll try to export it into Excel, and after converting it into Excel, we'll try to average the Excel data per row and export it to the front end. So after doing all these manipulations, after we'll be finally getting the Excel file, then we'll add another column for net attendance, and for which we'll calculate all the corresponding row wise average attendance for all the students, and we'll add it into that column and finally export it as a .csv file. The one thing I did not mention previously is that how will I be working with files. So I had an idea that I could work with files as an input as well as output in backend like this, that when the user scans a particular file, it will be stored in the uploads folder. Now when a particular user scans a file, then it adds as the corresponding maximum index currently present of that file in that folder plus 1. So let's suppose we have 7 files here, and if we were to scan and upload a new file into this folder, then we'll be traversing into this folder, taking out the maximum index at which the file is stored and storing it as the maximum index plus 1. So a new file will be stored as attendance8.jpg in this folder. Similarly, for taking the outputs, we will be storing and after processing, the outputs are stored in the corresponding index so that there is easy manipulation of the files, and after taking it as output files, the output files are taken in a way that the latest file is fetched first with the highest index which is being present in this folder. So now I will try to show how the application runs. So as I have already mentioned that the front end is built using React and the backend is built using Python Flask. So we will be writing first command as npm start to run the React part, and to run the Python backend we will be using the command python and the file name which is app.py. So when the front end and the backend starts running, we will open this tab in our browser. So this is our first look of the front end. There is home page, upload page. When we click on the upload page, we can choose a particular file which is a .jpg or a .png file which is to be uploaded. For example, I am choosing a file like this. And when we click on upload, it takes a processing time. So we will wait till the processing is completed. Here the attendance tab is gibberish and I will remove it in further updates. So once the file has processed successfully, shortly we will have a download option to download our spreadsheet file. So once the processing is complete, we had our download CSV option. Once we click on it, our file starts to download, and when we open it, we have a nice and good record for the image we have scanned into our Excel sheet. So these are the names which we have scanned initially. These are the total classes which have appeared. The column name and row name does not appear in the same line as we have as intended because of the quality of the image that was input and the type of input that was given to it. But here is the net attendance column which is addition which was not present in that image. So let me try to show you what image I have given as an input. So this was the image that I had given, and as we can see, and the type of column values and the column names are actually inclined at a 90-degree angle. That's why I believe it was not able to detect it. But as we can see, after the total percentage column, we have a net attendance column, which basically adds all the attendance and displays the net attendance of a particular person. So in this way, our PNG or a .jpg file has been converted into a .csv Excel file, which is available for us to download in no processing time, and an efficient output has been generated utilizing the power of all the OCR capabilities which we are using via Paddle OCR. So thank you so much for watching, and you can have my GitHub link as well as the deployment link in the description of this video. Thank you so much for watching.